Assalamualaikum. Now we're in chapter 2, multiple integral. So first we go to the double integral. So in double integral we have dy and dx, and before this in single usually ds kan. Okay, so for double integral for dy and dx, okay, they have a different interval. Okay, for example for x, interval is a and b, y is c and d. Okay, so how to solve the double integral? We integrate the inner first. For this one, we integrate on dy first. Okay, then after we have a result, integrate to s. Okay, this is the example. Okay, from here we need to integrate into dy first. Okay, so the interval 1, 2, 3 for x. Okay, then 2x. Then we need to integrate second square y. So we refer to trigonometric tables is the tangent y. So tangent y, the interval is 0 and pi over 4. Then dx lah. Okay, don't forget to write the dx. Then tangent y, we include tangent pi over 4 minus tangent 0 and dx. Okay, then tangent 5 over 0, and we calculate by using calculator, equal to 1. If you set radian in calculator, so you can directly tangent 5 over 4. But if you not radian, you need to tangent 45 degree lah. Okay, it depends on setting on your calculator. So tangent 0 is 0 dx. Okay, then just need to integrate into x. Okay, 1 over 3 2x dx. Okay, so dx, when you integrate, you will get 2x power of 2 divided by 2. Okay, then I can remove 2 here. I just leave x square here, and x square between interval 1, 3. Okay, then we include the interval 3 power of 2 minus 1 power of 2. So 9 minus 1, you get the answer is 8. Okay, I show in the slide lah. Okay, so you can also try for difference dx dy, but you need to change the interval also. Then you will get the same value, which is the value is 8. Okay, now I'll show you how to use the vertical strip technique. Okay, you need to evaluate these equations where R is a triangular region. Okay, with the vertex. Okay, I draw the triangle. Okay, this is the triangles. Okay, with the point 0, 2. Sorry, 2, 0, 0, 0 and 0, 2. Okay, then we need to find the interval for x and y by using vertical strip technique. So this is the verticals will move from 0 until 2. So for x, the interval is 0 until 2. Okay, then we need to find interval for y. So for y, there is between line y equal to 0 and the y equal to y equal to 0, and between, we need to find the equation for that line, so we can use y equal to mx tambah mx plus c. So how to find m? You use how to find the slope, so 2 minus 2 you get 1 lah. Okay, so we get negative x here, okay, plus 2 for c, intercept is 2, so you get y equal to negative x plus 2. So the interval for y is between 0 and 2 minus x. Okay, then when you get the interval, you can calculate lah from the previous questions. So integral for the a, we can use dx dy or dy dx. It depends on vertical or the horizontal. For this one, we use a vertical, so we use dy over dy dx. So x is between 0 and 2, and for y between 0 and 2 minus x. Okay, and the equation function is x plus y. Okay, they will solve lah by using double integral. Okay, we integrate x, we get xy plus y square over 2. Then we include the interval is between 0 and 0 and 2 for x, for y 0 and 2 minus x dx. Then we include the interval into x. Okay, 2 minus x plus 2 minus x square divide by 2. Then include the interval for 0. Okay, so I don't have space here, but I think student can calculate. Okay, so that is the answer. So that's minimum x 0, maximum x is 2. Okay, that is the interval for x. So interval for y between these two lines, so y equal to 0 and y equal to 2 minus x. Okay, then you calculate by using double integral, and the final answer you get is 2 equal to 2 over 3. Okay, now we go to the horizontal strip techniques. Okay, based on this shape, we can use the vertical, but vertical is more complex, so horizontal is more simple. Now I show you how to use the horizontal. So here we have a slope BC, y equal to 2x. So how to find the 2? You just use the slope equation for minus 0, 2 minus 0, so you get 2. So y equal to 2x. Okay, similar to slope AB, then you get the equation for AB, y equal to negative 2 over 3x. So here we use horizontal, so we use dx dy. Okay, you need to remember lah, we use vertical dy dx, so horizontal is become dx and dy. Okay, so the interval for dx in between 0 until 4. That is the horizontal line. And for vertical, for interval for y is between these two lines. Y equal to negative 3y over 2. Okay, y is the main title. Until Okay, so from this equation we get x equal to negative 3/2y. Okay, and the interval for y until y/2. Okay, so the interval for x between interval for y between 0/4. Okay, I'm sorry. Okay, then we integrate. So we have 1 here, so we get x with the interval for x dy. Then you include the interval. Okay, better I show you. We have a solution here. So area of region is equal to double integration dA. Okay, then we include y/2 plus y plus 3y/2 because y/2 minus negative 3y/2. So you get plus here. Then you integrate for dy, then include the intervals. Okay, integrate for dy, y kuasa 2y power 2 divided by 4, and 3y power 2 divided by 4. Then you get the answer is 16 units. Okay, 16 units square y square because this is the area, the formula for area. Okay, now I show you the double integral for non-reticular regions. So we have a curve here and the line here. So the curve is y minus x square. So to find the point where is the location, so we can use this equation, and negative x square minus 3x plus 4. Then you can use the factorization, or I'm suggest using by calculator lah, polynomial calculator. You setting in your calculator lah. Then you get the point is negative 4. So for the y axis you get negative 12. Okay, so to find area, dA, okay, it's a double integration dA. Okay, we use these two lines. So for this, the vertical is more suitable. If it's horizontal, so we have a similar limit, similar interval for x. So it cannot be used by horizontal. So vertical is more suitable. So by using vertical street techniques, we use dy dx. So x is between negative 4 until 1. Okay, and for y is between these two lines. Okay, between y equal to 3x and y equal to 4 minus x square. And here you have find the interval, so you can double integrate. So we integrate once, you get y. So y equal the interval for y dx. So 4 minus x square minus 3x dx. Okay, then you get the answer is about 20 unit square. Okay, this is how to calculate the volume. For volume is double integrand and function dA. That is the example. So by using double integral, find the volume of solid enclosed by plane. Okay, so here is the plane. So all have value x, y, and z. All have the value. So this is the plane. You need to remember from the chapter 1. And they show the limit is more x equal to 0, y equal to 0, and z equal to 0. Okay, so we need to find the interval for x and y. So how to find for interval x and y? X, the limit, the minimum is 0. Okay, so if not x equal to 0, y equal to 0, so it become below the line. Okay, but not in this case lah. Okay, how to find for x? So how to find x, the value for y and z we set to 0. Okay, so here x is equal to 3. So the interval for x is between 0 and 3. And how to find the interval for y? Okay, so here for volume, we use a dy dx. In this case, you can use both. You can use vertical or horizontal. Strict technique. So for here, I use a dy dx. So x is between 0 and 3. So for interval for y is between y equal to 0 and y equal to negative. The line here is negative. Okay, or you can use the formula and the equation there. So 2x plus 3y. Okay, z we set to 0. Okay, because it's 2 dimension. Then you get y equal to 6 minus 2x divided by 3. Then you include this equation into the interval for y. Okay, and to find the volume, you need to include the equation 2x. Okay, you can include the 6 minus 2x minus 3y. So z is equal to 0 because this is double integral 2 dimension lah. Okay, then for now, student can integrate lah as usual. Okay, when we integrate, you get 6y minus 2xy minus 3y square over 2. Okay, the interval is between 0 and 6 minus 2x over 3. And you can try lah to calculate. But here there is no enough space to complete the calculation. So the equation become very long. Then we include the interval for 0 lah, and blah blah blah. So I show the answer here. Okay, then we find the interval there. Then we integrate into y. Okay. Okay, I forgot to include the 0 interval for 0. And the answer is 6 unit square. 6 unit power of 3 because we need to find the volume. If you use the horizontal strip technique, okay, you need to change the dx, dy, and also the interval. Okay, if you use the horizontal strip techniques, you need to find for point for y is equal to 2. So interval for y between 0 and 2. Okay, the interval for z, that is the interval for z, that is the equation. Okay, this is the individual work. Okay, not the group work, sorry, individual work. So we have 3 questions here. First, evaluate and give a limit. So the first question is more simple. Okay. And second question, find the area. So you need to find the interval. So for second question, you need to draw first, and you can use dx dy or dy dx lah. It depends on the shape, which one is more suitable. Okay, and also give a line between x equal to 1 until x equal to 2. So that is the interval for x. And for last question, find the volume.